Circular integration is fun. You're going to love it. Just to review secant cubes, your notes were long. I had a sign error in your original secant cube notes. I apologize, but we're going to redo it now, and you're going to fix it. Sorry. When we did secant cube the first time, I had a negative in there that was wrong. It was a sign error. So don't trust those notes, or go back and fix them with what we're about to do. There's just one little sign there. Okay. When you did secant cubed, you used circular integration, but now you're going to use it on a lot of different problems. So let's just review it. Okay? You do ultraviolet Voodoo. Okay? Start by saying what would be a super wonderful antiderivative candidate for your dV? Secant squared. And therefore, du would be secant. Sorry, u would be secant, so du would be secant tangent, and v is tangent. You with me so far? Okay, then I get uv is secant of x, tangent of x, minus the integral of Voodoo. Tangent squared secant. Are you seeing where I'm coming from? Yes? The idea was to then use an identity to get secant cubed back. Tangent squared is equal to secant squared minus 1. Now that's wonderful because that brings back secant cubed in addition to a positive secant to the first. Right? Are you with me? Now the whole point then of circular is that you go in a circle and you get right back to where you started, in a matter of speaking. Secant cubed is still on the left, and so I can move that bad boy over and combine it to get two secant cubes. The left side is done. The right side is secant tangent plus, what's the antiderivative of secant? Pretty good, pretty good. Technically then this integral is done and you have a plus c over there, but let's move that 2 over, and the answer to our question is 1/2 secant tangent plus log secant tangent. Throw the c off to the side. Are you following? Okay then. This idea comes in handy when you get an integral that's a product of two things that don't really go away. E doesn't go away. Cosine doesn't go away. Just keeps coming back in circles, coming back for more, right? Integration, or circular integration, then will help. The good news is you can't really screw it up if you use integration by parts, because either choice for you will work. All right? So the good news is you'll be good either way. The only question, I guess, is would you rather take derivatives or antiderivatives of cosine 2? Derivatives, okay. Then I will let u equal cosine of 2x, and dv will be e to the x dx. Meaning that du is negative sine 2 sine 2x, and v is e to the x. Oui, oui? Oui, oui. uv then is e to the x, cosine of 2x, minus integral of Voodoo is negative 2 e to the x sine of 2x. 10-4, good buddies? Roger that. Okay, well then, that's not really like that one, so we're not ready for circular integration or combination yet. We must do it again, okay? Now, I told you it doesn't matter which you choose, and I was sort of correct, but I will tell you this. You must be consistent. If you use trig for u the first time, you should use it for u the second time, or you are going to undo what you just did, and you really will be exactly back where you started with no change. So you should be consistent. U is now sine of 2x. I'm going to cancel out those negatives. Do you mind? Okay. Yes. So u, yes, I do mind. Don't do that. U is sine of tx, and dv is, you could put the 2 up front or just call it part of your dv. What do you want to do? dv is 2e to the x. You guys just can't agree on anything. Du then is 2 cosine of 2x. That's good. That'll be helpful in a second. And v is 3 to the x. Okay. V to the x, cosine of 2x, plus uv is 2e to the x sine of 2x minus voodoo 4 e to the x cosine of 2x. Do you see where I'm coming with the 4? Yes. Okay. Now that's beautiful because that is right back to the integral we started with.
No, thank you.
Did I make a mistake?
No, you're right.
Okay. So when I move that integral over, I have 5 e to the x's equals e to the x cosine of 2x plus 2 e to the x sine of 2x. At that point, it feels appropriate to put M on C, although I guess you could wait to the very last step. Your answer then to the original problem with the 5 move is 1/5 times the quantity e to the x cosine of 2x plus 2e to the x sine of 2x. Plus C. Okay? For arc length. Okay. Are you good so far? Okay. Now let's go tabular integration. Come on, Ryan.
I'm so sorry.
That's a lot of writing. ¿Listos? What?
Are we ever going to have to do arc length?
Sure.
With the square root?
Yeah. You bet. Ready?
I need like a page for like one problem.
Okay. All right. So the next is sometimes you're going to see you're going to have to do repeated integration by parts to get rid of the power. To get x squared gradually out of power to x and then constant, you would have to do integration by parts twice, sometimes 3 times. Now, that gets pretty tedious, and there's a kind of a gimmick. It's not really a gimmick, it's just a notation-wise. Makes it really easy, and you can integrate this problem in maybe 1/4 of it, okay? So to appreciate where the shortcut comes from, I need the long way to look at so you can see why the shortcut goes what it does. So by integration by parts, you would let u equal x squared, dv is e to the x, du there is 2x, and v is e to the x. My first result then is x squared e to the x minus the integral of 2x e to the x dx. Do you agree? All right. I still have a product though, so I'm going to do integration by parts again. Now I'm going to let u equal x or 2x, whichever you prefer, and dv is the rest of it. Du then is 2 dx, and v is e to the x. Be careful when distributing the negative. X squared e to the x minus, I use brackets to enclose my whole ultraviolet voodoo to come. uv is 2x e to the x minus the integral of. Okay? So I get x squared e to the x minus 2x e to the x minus 2 e to the x plus c. Do you agree? Okay. By wait, you need to go ahead quickly.
That's exactly.
Okay. Did I lose something or make a mistake? So this should be plus. Okay, you're right. My bad. Sorry.
Almost had to do it again on the
My bad.
first day.
Okay, I'm going to contradict you. Okay, so tabular integration is meant to condense this. Throughout math, there's all these cool little shortcutty things that kind of strip off a lot of the writing and just focus on the what makes your final answer. So in this case, you make a table a lot like you do here, except in this time you're going to do u and its derivatives all the way down. And here will be dv and its anti-derivatives. The choice is still the same. We chose from the original problem that u would be x squared. But now, instead of doing this in bits and pieces, we're just going to crank out derivatives until they go away. So the first derivative is 2x, then 2, then 0. You continue until they go away. dv is e to the x, and you anti-differentiate these until you basically match the last column in that one. You follow me?
Yeah.
Okay, now we know that uv is our first answer when we do integration by parts. Looking in this table then, that's u, but v is there. Okay, this is dv, so our v is here. Here's uv. Now you'll find then that those diagonal products actually continue all the way throughout. So our answer is going to be x squared e to the x, 2x e to the x, and 2e to the x. Besides them, definitely the first one is positive uv, so it's positive. But the first time we do integration by parts, it's minus what's next, and so the next one will be minus. But the third one is minus minus, or two negatives, and it is positive. So you have alternating signs, and your answer is x squared e to the x minus 2x e to the x plus 2e to the x. So let's see. Okay. Yes?
Does it always start as positive?
It always starts as positive because UV always starts as positive.
Wow, that was so
Yeah, it's super quick. Okay, so should we try one example or just go on to the homework? Okay, then here we go. This one's on the homework, so you'll be able to do that one on the homework. You mean try one on tonight's homework or go to homework questions from last night? Okay, this is number 6, is it? Are you lying? Oh, okay, that's not 6. You liar. Oh, sorry, I called you a liar. Yeah, 6. No 6. No, you can just write U and DV now. I just wanted you in your notes to understand. I'm banking on that you can do some mental anti-differentiating without you subbing and all that. So what's the antiderivative of e to the 2x? 1/2 e to the 2x. Then our final answer is x cubed over 2 e to the 2x, 2x minus 3/4 x squared e to the 2x plus 6/8 or 3/4 x e to the 2x minus 6/16 or minus 3/8 e to the 2x plus 6. With me? All right, questions on 121. 10.
Yeah.
21, 20,
10.
and again. Just in case I screw up the first time. Okay? John?
See, I like 20. I want 22 instead.
Not 20?
Not 2022. I know. I got it.
You still have to sit there and think.
Okay.
Really?
Right, number 10. Oh.
Yeah, B and B is not
Okay, I assume you had an A, B, C, and a D. A over X plus B over X squared plus C over X plus 1 plus D over X plus 1 squared. I assume you started 5. Okay. If negative x cubed plus 2x squared plus 4x plus 2 equals A times x plus 1 squared, B times x plus 1 squared, C x squared x plus 1, and D x squared. Do you agree? Yes, you do. So let's let x equal 0. If you do, then 2 equals B, and that's all. B is 2. Boom. Okay? If you let x equal negative 1, then you get what? 1 plus 2 minus 4 plus 2 on the right. On the left. On the right, you get nothing, 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 D. So D is 1, right? Okay, so I'm going to put those in D so I don't forget and think I have more variables than I do. Now, in terms of strategy here, you could look at x cubed. If you kind of get a little experience under your belt, you'll look at x cubed and say that's not helpful. Okay, and it's because you have an ax cubed and a cx cubed, and you don't know a or c, and so to say negative 1x cubed equals a plus c x cubed doesn't really go anywhere, right? Likewise, you could do x squareds. I took a minute to write ax times, at least expanded. I needed to see these guys here. 2 times x squared plus 2x plus 1. C times x cubed plus x squared plus x squared. Okay. X squareds are actually probably the worst possible choice because there are ax squareds and constant and cx squareds. That also, it just goes nowhere. X squareds have a's and c's in them as well. You with me? The x's, you want to start, in terms of saving yourself time, you want to start finding, okay, what kind of term in x does not have a's and c's? X does. Ax is there, but c does not have an x. And so you want to focus on that. You know that a plus, how many x's here? 4 plus none, x's needs to equal 4 x's here. If a plus 4 needs to equal 4, that implies a must be nothing. Now you can use the a plus c. If a plus c equals negative 1 in x cubes, then that implies that c must be negative 1. So the problem then is the integral of no first term, but b over x squared. What's b again? 2 over x squared minus 1 over x plus 1 plus 1 over x plus 1 quantity squared. However you want to do it.
You with me? Does that get you going?
Yeah.
Okey dokey.
21. Question on 21.
Yes.
21 is yield partial fraction decomposition problem. Can you tell me the decomposition, or is that the problem?
I need another to get to decompose.
So,
How did you
because
know?
A equals negative, or A equals 1 and B equals negative.
So 1 over 4n minus 3 and 1 over 4n plus 1, like that? Okay, cool. And it's still
How do you
some.
decompose it?
How do you decompose it?
No, how do you know to decompose it?
Oh, if you see, for the time being, if you see a product of two fractions in the denominator, it's one of those partial fraction decomposition. Telescope stuff, okay?
Okay.
Okay, so then, let's pick up from there. Depending on you, you might be able to just see the pattern or not. I definitely cannot. So I'm going to plug in a point or two and see what happens. When I put in 1, I get 1 minus 1 over 5. Then I get, let's see, when n equals 2, I get 1 over 5 minus 1 over 9. Do you agree? I think I see it at that point. I guess I could do one more. 3 is 1/9 minus 1/12, or 1/13, and so on. Okay, so sum 1 is 1 minus a fifth. Sum 2 is 1 minus a ninth. Sum 3 is 1 minus a 13th. Our goal is to make a connection between the number of the sum and what's going on in the fraction each time. Don't start from scratch. Use this as a guide. You know it's going up by 4 each time, right? So you would be wise to say something like 1 over 4n something. What's the connection there between that number and that number? 4n plus 1. Okay? That works. Check to verify it works each time. And then you're rolling. The limit as you add infinitely many terms approaches. Okay? 22 is still a question.
Yes.
Okay, so 22, it says, does it converge or diverge? If it converges, find its value. That won't always be the case, but in this case it
Discover
is.
more, discover cone, hidden cone, and absolutely please comfort tenants.
Okay, did you see that this is geometric? Okay. I can anticipate one problem being with the R. Yeah, if these have the same exponent, or even if they both have some kind of an exponent, I would recommend you put them together.
Trust you. No longer trust you.
Because that will be your R. So R is the absolute value of negative 1/2, which is 1/2, which is less than 1.
No, it's free.
It converges, so now we use our
R is
I don't know where this started. Actually, it started at negative 1/2 times 4, so negative 2. Feels like it starts at.
Okay.
I'm assuming it started at 1 actually. I don't know.
Oh, me too. No.
3. Yes.
Okay, that makes sense.
You get it?
Yes, thank you.
You're welcome. Okay. Does anybody need 9?
Could we talk about 19?
Sure. 19, yes. Sure, I better write this. Okay, so John,
Elizabeth, time.
June, I, Liz. Check.
You know, we really should just put a sign up on your board or something.
Yeah. Yeah. It's required English motion.
Can't you change the number?
I could if I might as well.
Just put like,
Just
Put a 100 on there.
No, just kind of like the maximum number of chairs or.
no, but the problem is that once people will still come.
Yeah, then I'll still do
And then
it.
there's
You
gonna
can write
be
me
47. I only have 5.
No, but then you'll say no, because that's sorry.
It feels like a few people that aren't very persistent are being turned away right now. You know, there are some people that say, "Oh, it's fine, never mind, I'll listen around." That's
Or you
good.
could just.
But I love that.
You pick one for 6.
Can I do that though? Can I write that sign up on your board?
Sure, go for it.
Yeah, cause
Yes. I will require you, I have a list of to be required.
Okay, here we go. 19. You said 19. Do you still need 19? Here we go. Okay. Did you have an idea?
oh my god, that it looks like the E.
Yes, there you go. Beautiful. All right. After that, then you have to know what is the E and how does this need to be tweaked.
E is defined as this. Wait.
Yeah.
Okay, I write that and then I focus on the inside. I say let x over 3 equal 1 over u. You with me? So that upon substitution, this becomes 1 plus 1 over u. Then you need to tweak things. First of all, the limit. If x gets small, you could think of it this way here. Let's go with, you could also say u is 3 over x. Wouldn't you agree?
Yeah.
If x gets small, then u gets large. So it becomes the limit of u going to infinity, which is good, because that's what it's got to be. Second, instead of 3 over x is equivalent to u. And so this is the straight up e, the 3 actually washed out. The 2, if it was here, it would have been e cubed. Or if it was there, it would have been e cubed. But they really washed, or e to the 1/3. And they really washed each other out.
Okay, just.
All right, yes.
So on, 1 point, so for 14, for that, would you not do that? Would you do the A of limit of A? of the
Exactly.
Okay.
Unfortunately, you put that in. I assume it was delayed the groundwork for the next day's lesson. So we hadn't covered that yet. But yes, now you know. You would say the limit of terms is not.
Okay, great.
Okay.
All right. I will require a multitude.
We should have sweet Wednesdays.
Sweet Wednesdays?
Wednesdays.
I love sweet
Or
anything.
sweet Thursdays.
Why Thursday?
I don't know, because,
Today's
today's
Wednesday,
Wednesday.
that's
Yeah. Pretty much.
It's hard to argue with that logic.
Yeah.
I'm down. Unfortunately, it's hard to organize it. But anytime you want to bring in sweets, go for it.
Will do. All right, see you this week.
Have a good day.